Right. Okay. Partition labels. You're given a string S, and we want to partition the string into as many parts as possible so that each letter appears in at most one part. Okay. Each letter appears in at most one part. Okay. For example, the string A, B, C can be partitioned to A, B, and C. Okay, because A's are not, if A's in the first partition, then A can't be in the second partition. The partitions, no, wait, so that as many parts as possible so that each letter appears in at most one. The partition such as ABA and BCC, or ABA and BBC, so the first three and the last three, doesn't work because B appears in both parts, and similarly if partition to 2 piece, well, A doesn't work and B doesn't work, C works. The partition is done so that after concatenating all the parts in order, the resultant string list should be S. Return a list of integers representing the size of these parts. Okay. So, interesting. So, for example here, if you have all this jazz, the output is 978. Okay, so you're giving back the size of the partitions, I think. So first 9 letters, because you don't want A to be appearing again. And then the second part is going to be D to this E, because you don't want the E to be shown again. And then last one is that. And here this doesn't work. Okay. So if you want to partition something as much as possible, it feels like you should know when the last and first thing of it is, the first and last of each letter, because you can't, you're not going to be able to partition anything in between those. So I'm going to determine first and last appearance of each letter. And this isn't going to be enough, but it's going to be a start. So I'll do a what should be, so for each letter, let's say first is going to be -1 times 26 letters, and last will be -1 times 26 letters, and how should I do this quickly? For each letter in, let's say, alphabet is A, B, C, D, E, F, G, H, I, J, K, Q, R, S, T, U, V, W, X, Y, Z. So let's go ahead and just define a quick way of getting the index. Return let's say k is the ordinal value of the letter A, and return the ordinal of the letter minus k. And so for each letter, so if I go through the array once, the last time something appears is the, and if I set the index, so for each index in the range of n, where n is the length of the string, if I say the letter is whatever it's at the index, and I'll say the last of the offset here of this letter is equal to whatever index this is. And then similarly, if I do it in reverse order, n minus 1, negative 1, negative 1, letter is equal to this index, and the first of this letter is this index. This doesn't use if statements. But it just relies on the fact that if you go through multiple A's within your string, the last time that you see an A is the last time you actually input it into the array. So it kind of replaces it. Similarly, if you go backwards, the first time you see it is the last time, is the first letter that the first instance that appears in the array is the last time you kind of overwrite the array value. I'm just gonna go ahead and put each letter in alpha, or let's say, I'm just gonna do a quick sanity check here. For each index in range of 26, I'll print out the letter, print out the index, letter, and the first and last of it. First and last of this. And then I'll just return. Okay, so A appears at 0 first time, 8 last time, B appears at 1 first time, 5 last time, and a lot of other letters don't appear at all. A doesn't appear, E appears 0, 8. Okay, that looks all good. So next up is going to be going through the string, and I'll just do a greedy approach, I think, where whenever I see a letter, I know the partition needs to extend to where the last occurrence of that letter is. And as I go through each element between that, so for instance, if I see A, I know that this thing needs to extend to this A here, and so I keep on going, and I see B here as I go to that last A. So that means I need to extend it to the maximum of whatever the last A is and whatever the last B is. So because the last B is within the last A, I don't really care. this A is where you found, this B is where you found the C, now extends it further if possible, but it doesn't. And then it reaches the last A, and then it knows that that's the partition. So yeah, I think it's just a greedy approach here. So for each index, let's say end index is 1 or 0, one of those two. And so the answer is an array here. So for each, is the end going to be 1 or 2? I think the end should be 1. For each index in range, where end is tracks the last occurrence of letters in current partition of last occurrence of any letter. Okay, so for each index in the range n, the letter at this index is going to be s at this index. And then I guess I don't really need to know first. I just need to care about last. Last of this, last of the offset of this letter is offset of this letter is going to be equal to is going to be no. So what I want is the end to become the maximum of the current end and the last of this thing. And then if we're at the end, then we can say this is a good partition. So answer dot append. I guess I need to know when the first partition was. So the start is going to be, you can either say the start is 0 or 1. Actually, the end should be 0. Let's say I'm going to, let's say start and end are inclusive. Start and end are inclusive of those indices for the partition. So if it's inclusive, then it should be n minus start plus 1. And now that the value is set, the next partition is going to start at index plus 1, and the next n must start at index plus 1. I guess it doesn't matter. The n is going to be reset to this spot anyways. Is there any ways to make this faster? I guess if you, maybe you can do a set, or the set will, I wonder if you can do this much faster, because there's only 26 letters, so there's at most 26 partitions. So you don't have to do like n operations. Can you do this in 26? Alright, let's see how slow this is and optimize it afterwards, maybe. And then the last partition needs to be appended. So it should be the n minus whatever the start one is. And return the answer. Okay, maybe the last one. Okay, I guess maybe I'm incorrect in that assumption. I don't need to append 0. Yeah, this definitely works, but could be. I don't think it needs to be going through all n indices, maybe. How would it work if it just went through the 26 letters? So there's some letter that you start with, and then that increases to some letters that you start with, and that increases to some ending index. How do you know which letters occur between them? Well, I guess if you were doing one pass to determine which letters, where they are and where they end, I guess you can't really, say that going through 26 is going to be that much faster, because you already went through all n. I wonder if this could be faster if I just used a map dictionary rather than an array that calculates the offset each time. Actually, maybe I should convert everything to numbers in the first pass. And then I'll have to do a bunch of offsets later on. Okay, I'll try that first up. So for each letter in S, let's say nums, is going to be appending the ordinal of that letter minus k. Okay, so I just have a nums array, and then I'll have to worry about alpha or whatever's. So for each index, I still have to worry about it when I actually, yeah, I still have to worry about it. Actually, now I'm just dealing with nums rather than s. Okay, so the letter is actually nums that is index, and the last of this letter, which is that number actually. Okay, and nums of this index. Letter is nums, and last is going to be last of this letter. Okay, I think that still works. And actually, I don't need to know where the firsts are. Just care where the last ones are. I don't know if that works. Is the tabbing still wrong? Alright, I think that was slightly faster, but not fast enough. Okay. So, marginally better. Turn a list of integers representing the size of these parts. So, I have my numbers array. So I know where the first and last of any number, or know where the last of any number is. So what if I just did a bunch of leapfrogs? So for instance, I go to the, I start with A. Start with A, and then no, that doesn't work. Like then I see the next letter D, and the first D doesn't occur before then. I don't know. I need to care about everything in between though. So would using a set work? So I go A. So I have A, B, C, D, all the way to Z as a bunch of intervals. Oh shoot, this is that one interval problem again. How to quickly identify what overlapping intervals there are. Oh shit. And you can do it. I think you could do it. How did I do it before? Oh gosh. Just a couple days ago, and I already forgot. Was the count the days without meetings? For each start and end of the meeting, if the start is greater than the end, answer equals. Was this the overlapping thing? Yeah, this had some overlapping issues. Otherwise, move the end date to be the maximum. So how did I do this one? So I sorted based on the starting. I sorted based on the starting. Okay. I sorted based on the starting index that something is found, and then I process it in order, the starting indices, and if I see that the start is past where the ending is of the current partition, then I can say that they're not overlapping. Okay. Okay. Yeah, I think that makes sense. So I do need to know where the start and ends are. So what I can do here is I can say that let's see, say for each number that has some value, so each index in the range of 26, if the first of this index is equal to -1, then ignore it. Otherwise, go ahead and append to an intervals array the first and last occurs. So first and last. And then I'll sort that. And then I'll go through in order. So for index in the range of the length of intervals, if I have current interval partition end, it's going to be currently, it doesn't matter, it's -1. So start, and actually I'll say partition end is currently 0. So start and end for this letter is equal to first of this and the last this index. And then if the start is after the current end, then I know that I can do a partition here. So I can say actually any partitions end and partition start as well. So if the start is after the partition end is after. Then the answer should append whatever partition it was. So partition end minus partition start plus 1. Else, if the start is if the start is at the partition less than, how could the start be equal to? How could the start be equal to the partition end? Oh, so if the start is, so if it's equal to, then it just extends it. So partition end is going to equal to the maximum of the current end and this partition end. And actually, I need to say here now that partition start should be this spot. And then I return the answer. Yeeks. Okay, so we got the 9. We got nothing right here. So let's go ahead and just do sanity check here. What are the intervals after I do all this? Alright, A is 0, 8, B is 1, 5, C is 4, 7, D is 9, 14. Okay, that's all correct. E is 0, 8, C is 1, 9, B is 3, 6, and D is 7, 7. Okay, that's fine. So you have partition start, it starts at 0, 0. And then it's going to go through first interval, which is 0, 8. The start is not greater than the partition end, so it doesn't do partition here. It should set the partition end to be 8. Then does the next loop. But it does actually say, okay, so say print index start end and what the current answer is. So 0, 0. Okay, so it doesn't. So it goes 0, 0. So after the first pass where it does A, it makes the partition end to be 8, which is great, and it doesn't know that the answer is anything yet. Next pass it sees B. Why is it making the partition end smaller now? Why did it make the partition end smaller? Oh, the start is not before the partition end. If the start is after. No, it should be doing this thing. Second pass, B is 1 to 5. 1 has a start that is not greater than the current end. So the current end should be the end here, which is 5 and 8. Say extending partition to there should be partition start and partition end. What do I care about seeing? I really care about seeing partition start, partition start, and partition end. Okay, so does the first pass 0, 8, second pass is also 0, 8. Okay, so the first answer is 9, and then it sets it to be partition start is 10, partition end is 8. Oh, gosh dang it. Partition end also needs to be set here. Okay. Alright, I have 9, 7, missing 8, 1, 1. 0, 0. The first pass shouldn't be Extending the partition to 0. So actually, I think maybe so start is greater than partition end. So the initial partition start should be 0, sure. The initial partition end, I guess, maybe I just set it to be the first value here. So the first interval. And then I just go through all the later ones. Okay. Okay, sure. I think I'm just missing the last partition. So, because it never actually, yeah, it never really counts for that last partition here. So answer.append n minus the partition start this one. Or is it just minus partition start? Alright. Let's go and get rid of some prints here. See how this performs. I mean, it doesn't go through as many passes of n, but it still goes through n passes. Oh shoot. Alright, let's see what is up with this test case. So 0 to 0. Okay. So there's one partition there. Yeah, okay. If there's a single letter partition, it doesn't really do that very well. So how did the other one handle single letter partitions correctly? I guess it does the extension and then it does a check actually. So it's not an else. So it extends. So it always tries to extend. Should it always try to extend? Yeah, I think no. How did I do it before? So the end is the last occurrence. Yeah, it should always extend it. Partition end equals max of the partition end and the current end. And if this index is at that end, then do the partitioning. And set the partition start to be the next one. I think this might work, and I think that would get rid of this pen at the very last. Doesn't work now. Yeah, I do need some logic here. This logic's not right. So you have the current partition, you can have some interval. You first need to check whether or not that interval should be extending. Whether or not that interval should be extending. So zero, first time you see it becomes 0, 8, and then you see the 1, 5. If you extend the 1, 5 to be, okay, this index is not the index of the actual string. This is the index of the one of the 26 letters. Okay, so this is incorrect. Yeah, this is just majorly incorrect. So we have another interval. How does it play out with the previous interval? So if the start is greater than is if the start is before the end, if the start is before the current end, then extend it. And then extend. Otherwise, if it's equal to the current end, the start is equal to the current end. The start can't be equal to the current end. If the start is before, extend. If the start is before the current is after the current end, start is after the current end. How do I get the creation of the single letter partition? Do I do a special test case or special condition for that? So you extend it, you extend it, and then you check. Actually, why does the single letter work correctly? Why didn't it actually work? So this thing now doesn't work at all. This should be else. And this should be the last one. Okay, so you have 0, 0. 0, 0 could actually create something. Yeah, so that doesn't quite work. So partition start, partition end. I can't just make this outside the loop, I don't think. Well, why can't I make it outside the loop? So the loop, whenever you see Okay, so the first time this does a pass, we'll actually do 1, 9. And then if it does 1, 9, then start is, it should append the end minus start plus 1. Okay, this should do 1. That's correct. And then the partition is for A, which is 1, 4. Partition is for A. It should be like 1, 9. Yeah, it should be 1, 9. So answer the append. Partition start should be wait. Am I doing first and last? Shouldn't I be doing intervals first and last? First of this index and the last of this index. Shouldn't this be intervals of this thing? Wow, I'm not sure how that bug went through. The heck? Okay, well that was faster. There's still some print on that last run. Oh, okay, sweet. That's good. Okay, so what did I do? I don't think I need to know all these offset stuff. So I converted, I think I can make a list comprehension way of saying this. So nums is going to be k for nums is going to be ordinal of the letter. K. K equals ordinal A, and nums is going to be ordinal of the letter minus k for each letter in S. I think that's the correct syntax for it. Okay. And then the first and last, that's going to be going through the array, going through the string, determining when the first time you see something is, when the last time you see something is. And I can just use the nums value as the nums is now just, the letter is now just the index. I don't think I can go through that any faster. I don't think if statements actually help that at all. Okay, and then I have an answer. Do I need start? This is all old stuff. Start. I don't think I need. I have a later start here. So, well, I have a later answer array. So I have my intervals. So for each letter, if it's actually some letter within the string, I guess I can say if letter yeah, but the first time I see the letter is, if I see the letter all, then I append the first and last occurrence of the letter to some intervals, sort the intervals, and then say that my first interval is where my partition start and end are. Have an answer array for every later interval. If the start and end, if I take the start and end of that interval, is there a way to do this without an if statement? I think you need an if statement. You make the max size. If the start is bigger than the current end, then you create a new partition. And then start is not bigger than the last one, and then you just extend the current partition. I think this is as close as I don't not have an if statement there. And then make a partition for last. Okay, so I think that's as optimized as I'm gonna get it to be. I'm not sure how to optimize it further. Okay, so summary. This is consider. Okay, so create intervals for each letter, first and last occurrence. And I use for purely optimization purposes, converted the basically the char array for the string to an integer array where the integers are offsets of letter offsets from A. And then this is going to be find when sort the intervals, and then process the sorted intervals extending any overlap and creating partitions when overlap does not exist with current partition. So you go through each interval, starting with the earliest one, and because anytime you have an overlapping interval, that just means that like there's some letter within the current like bounding partition that for instance A goes from here to here. If you see B and B maybe ends up over here, then you need to extend out the partition. But if you don't extend out, like if B actually starts after the last occurrence of A. As you process it in sort order, then you create a partition, and then obviously you need to create one final partition. Like the way that I coded the for loop, it didn't actually detect immediate need to partition if there was like a one element, or if the current partition, with the current index ends with the current partition. I'm not sure how to say that. For any remaining stuff. Alright, time complexity for this one is going to be O of n to determine first and last, and O of 1 to determine overlaps. That's because you're actually just going through all 26 letters and not going more than that. I guess you do, and I guess you do like sorting 26 intervals. So, and like 26 log 26 for sorting intervals. Base complexity. This will be O of 1 for constant. Track of intervals and first and last. Your array size are all 26. Alright, cool beans.